Weather-based electricity consumption. Prediction using big data analytics model. Abstract electricity is being consumed in every home at present time. We are using electricity for lots of purposes like watching television, charging cell phones, electric bulb and many more things. Analyzing this electricity data will give us a better understanding of how consumer consumes electricity in their daily life. Apart from user daily electricity consumption, there are also external factor which plays a major role in defining the amount of electricity consumed. One of the major external factor is weather. Like in a sunny day, a family can use cooler, AC, refrigerator, which increases the electrical consumption. Similarly, on a cold day, user can use heater, geyser kind of things. By inspecting the convolution, volatility, and variability of the user's electricity consumption behavior and weather data, this paper proposes a machine learning model using data analytics to analyze this behavior. A big data analytics model for tracking and monitoring household electricity consumption based on external factor like weather is developed. Using the big data analytics techniques, machine learning algorithms and descriptive analysis of data obtained from weather and consumers, the model provides the required information and prediction. Keywords: electricity consumption, weather forecast, BDA models, data analytic techniques, machine learning. Introduction. In this era of digital world, we can see that electricity has become an integral part of our day-to-day life. From small equipment like bulb, blender, toaster to large appliances like television, washing machine, refrigerator that we use at our home runs on electricity. Similarly, in each and every sector like aerospace, transport, computer, telecommunication, construction, education, medical industry, there are multiple appliances which can't be run without electricity. So from this perspective, monitoring and consumption of electricity becomes more paramount. Nowadays we can observe that everyone is recklessly using electricity, which can lead to scarcity of electricity in future as well as wrecking situation for upcoming generations. Apart from electrical appliance, there are multiple other factors which affects electrical consumption in home as well as in various sectors. Weather is among one of the most important external factor. So it is very important for us to monitor electrical consumption based on weather so that we can save as much of the energy and contribute for the betterment of future generation. Thus, using data analytics technique and machine learning method, we propose a model to analyze the user's electricity consumption behavior based on external factors like weather. 2. Literature survey. Roemadala has lean errors from 3 were motivated to predict the household electricity consumption and also monitor it. The electricity consumption data can be easily extracted from the smart meters, billing system, and also power station. Big data analytics techniques have been used for data pre-processing, data exploration, and also preparing data which is fit for model prediction using machine learning. They used previous electricity consumption dataset and performed descriptive and predictive analytics. Linear regression is the algorithm that they used to predict the electricity consumption. The main limitation of the paper is that there is no usage of external factors like weather dataset in electricity consumption, which otherwise plays a major role in electricity consumption. W. Zhang, X. Dong, H. Li, J. Su and D. Wang from 1 were motivated on finding the abnormal electricity consumption behavior with the help of feature engineering and unsupervised learning. The main focus of the paper was on feature selection and not on algorithm selection. Using unsupervised learning, they were able to detect if there is any electricity theft by finding anomaly in the data. Deep learning algorithm was used to find the feature. Dimension were reduced with the help of factor analysis. The dataset which was used was of the industrial park. The paper is not only useful in finding the abnormality in electricity consumption behavior but also helps in extracting the best feature on which the consumption prediction can be performed. The paper has a disadvantage of lack of information on which feature selection strategy to be followed for accurate consumption prediction. S. Shan, B. Cao and Ziwu from 2 were motivated in building a model which would predict the electricity consumption more accurately and stability. They proposed an ensemble model and called it Gravity-Gated Recurrent Unit Electricity Consumption Model. They used 2 years electricity consumption dataset of a 5-star hotel building in Shanghai, and to test the generalization capacity of the model they used dataset of office building. The paper has 4 evaluation metrics for knowing comparing the accuracy of model and extracting the best model name: maximum MAPE, minimum MAPE, average MAPE, variance. The paper has a disadvantage of no external factor being considered for predicting the electricity consumption. Prakulkarni D.K. Chitra from 4 were motivated in designing techniques to collect electrical consumption data from household. With the help of Internet of Things, they proposed an energy management system for smart home. Energy management system would contain data acquisition module from Internet of Things and has a unique IP address which is connected to wireless network, useful for transferring data from home to cloud servers. The consumption data is collected by system-on-chip module from each device present in the household. The data collected can further be used for performing analysis and prediction. The paper had no algorithm proposed on how analysis can be performed on the data collected. 3 additional work in our system other than normal electrical consumption. We are also including that how external factors like weather and many other factors affect the electrical consumption at home. The algorithm and approach we will use can vary based upon the accuracy rate. We will use data mining features like cleaning, pre-processing, clustering, descriptive and predictive algorithm, and also machine learning concepts. The various stage of modeling will include A. Data collection and extraction. B. Data transformation. C. Data analytics and machine learning algorithms. The Python libraries like Matplotlib, NumPy, and Pandas will be used. 4. Implementation. In this model we will use data analytics techniques as well as machine learning algorithms, which will sum up to 5 layers. The layers are data source, data exploration, data pre-processing, data visualization, and model implementation. A. Data source. This layer is very first stage of our model where we look for electrical consumption data and weather data from various available resources. This comprises of data sets like how much electricity a particular room uses in 10 minutes duration, in addition to the temperature, humidity, and various other factors. The consumption data will come various appliances from different rooms like washing machine from bathroom, refrigerator from kitchen, laptop from living room, air conditioner in bedroom. The data acquired at this layer will be used as an input for other layers. This data will first go through various data analytics techniques, and then we will use processed data into machine learning model for training and testing, so that we can get consumption prediction as an output. Figure 1. Data variables. In Figure 1 we have 29 columns and 4 rows with each column consisting of 19,735 values. B. Data exploration. In this layer of our model we will explore the data in first stage. We will use Python libraries like Pandas, NumPy for importing various functions which can help us exploring data in a much better way. First we will rename the column name of our data set according to our convenience for the model. Figure 2 depicts the count, mean, standard deviation, minimum and maximum value of data set. We will use describe method to get more insight details of our data set. Figure 3 null value. Figure 3 describes null value in each column. Since this raw data set may consist of null values, so we will use this null method to check how many rows contain null values. Now we will rearrange the data columns like we will merge all temperature into single array. Similarly for humidity we will do the same. Lowest temperature inside the house is 14.89 deg and highest temperature inside the house is 29.85 deg. Outside the house the lowest temperature is -6.06 deg and the highest being 28.29 deg. The lowest humidity inside the house is 20.60% and the highest humidity inside the house is 63.36%. 3/4 of appliance consume less than 100 watt. Now we will separate dependent variables and independent variables for training and testing. See data pre-processing. In this layer of our model we will remove null values and divide the data set into dependent variables and independent variable. The dependent variables are the variables which rely gets affected by independent variable, whereas independent variable are not affected by any factors. In our model appliance is a dependent variable whereas others are independent variables. This process is then followed by dividing the dataset into training and testing dataset, which is required for machine learning model. Our model will use 75% of dataset as training dataset and 25% as testing dataset as depicted in Figure 4. From data exploration we were able to notice that light variable consisted of around 14,000 values, so we decided to drop the light column from our dataset for the betterment of our prediction accuracy. The data that we have contain large difference like in appliance consumption vary from 1 to 1000 and other variables are varying from 1 to 100. So if we directly feed this data to our machine learning model, the model will become biased. And it won't predict correct consumption, so to remove this anomaly we will normalize of each variable into a common range. For this we will use standard scalar from sklearn library. Figure 5 Normalization. Figure 5 shows the normalization of dataset. D. Data visualization. Datasets available are in CSV format, which have easily imported and processed using Python libraries using Jupyter IDE. Built-in features like scikit-learn, NumPy and Pandas have been used for the whole process, and pyplot, matplotlib is used for visualization. Initial exploratory analysis is done to understand which features are most impactful and critical to the research. The most differentiating feature here is temperature and humidity. Figure 6 shows the distribution of variables. It is used to detect the anomaly present in the dataset. From Figure 6 it is evident that variable light consists of numerous zero values. All the temperature variable follow normal distribution except parent room temperature. All the humidity variables follow normal distribution except outside humidity as it has many zero values. The two random variables also contain numerous zero values. Data visualization helps in making the model more accurate in predicting the consumption. Figure 6 Distribution of variables. E-model implementation. In this layer we will use processed data to feed our various machine learning model and predict electrical consumption based on that. We will implement following machine learning model. A. Linear regression. B. Support vector machine. C. K-nearest neighbors. D. Random forest. A. Linear regression. It analyzes specific relationship between two variables and gain information about a variable through values of other variable. There are two types of variables: dependent and independent variables. Independent variables are the variables which are given as an input to the system. It can also be called as predictor. Dependent variables are the one whose value gets affected by change in other values. They can also be called as response variable. Linear regression widely focuses on relationship between dependent and independent variables. First-order linear model is given by y-dependent variable x independent variable b0 y-intercept b1 slope of the line error variable. In linear regression we have cost equation which gives us information about how much difference is there between values predicted by model and actual values. Thus we use gradient descent to loop through our data and find the lowest cost error, which gives us most accurate linear regression model. B. Support vector machines. Support vector machine is a powerful supervised machine learning algorithm that works on linearly and non-linearly separable data. It finds an optimal hyperplane that best separates our data, so that the distance from a nearest point in a space to itself is maximized. Hyperplane is a plane of n1 dimensions in n-dimensional feature space that separates the two classes. Like for a 2D feature space it will be a line, and for 3D feature space it will be a plane. Hyperplane is basically the decision boundary for our classifier. We will separately classify data based on which region of hyperplane the data falls. H, x, equals wt. X and bw weight vector b scalar bias. C, k-nearest neighbors. It is used for both classification and regression problems. It stores all available cases and classifies new cases based on similarity measures. A case is classified by a majority vote of its neighbors. The case is assigned to the class most common amongst its k-nearest neighbors measured by a distance function. Classification becomes difficult when the number of dimension increases. It provides high speed and better performance as it takes less time for model training. D. Random forest. Random forest is a popular algorithm which is a part of the supervised mastering algorithm. It can be used to solve both regression and classifications problems. Random forest is based on the idea of ensemble learning, which happens to be a procedure of pairing several classifiers in order to solve a complicated problem and to boost the overall performance of the algorithm. We are using root mean squared error to calculate the efficiency of our model. RMSE equals v, dash, 2 slash, equals 1. P predicted value O observed value N number of observation. With the help of this formula the accuracy of model is calculated and it shows the error value of the model. V results discussion. After performing all this machine learning models, we get to know their train time and root mean squared error of each model. It is evident from the graph that linear regression is worst performing model among the 4 models, whereas support vector machine is slightly better than linear regression. K-nearest neighbors show drastic improvement in accuracy in comparison with above 2. But the best performing model out of all 4 models is random forest model. Figure 9 Training time comparison. Figure 9 shows the training time comparison among different models. It is evident from the graph that random forest model takes highest time to train, whereas support vector machine takes second highest time to train. Linear regression and k-nearest neighbor takes very less time in comparison with other 2, with k-nearest the lowest among all. 1. Least RMSE score is by random forest 0.632. Linear regression regularization was worst performing model. 6. Conclusion: existing system monitors electrical consumption without including any external factors. People will recklessly use electrical equipment and it will be difficult to manage consumption and save energy using this model. With the help of externals factors such as weather dataset we will be able to predict daily electrical consumption behavior in a much efficient and a correct way. Apart from linear regression we are using other training model which will predict outcome with less error percentage. Because we are using the pre-trained model in our project, which will reduce the cost of our model and also reduce the cost of daily electrical consumption. With the arrival of electrical cars in market, it seems in future most probably there will be crisis of energy, so next generation can efficiently use this model to somehow control the energy crisis. This model will help predict the electricity consumption with the help of external factors like weather data. Future works should include research on industrial electricity consumption and how to reduce the electricity consumption in order to reduce the pollution.